lots of different scales for measuring temperature. Fahrenheit and Celsius are the most commonly used in everyday life, but Fahrenheit is almost never used in science. The Celsius scale is based on the freezing point and boiling point of water. But even the Celsius scale isn't the best, because absolute zero on the Celsius scale is negative 273.15 degrees. The Kelvin scale is based on absolute zero and starts at 0 Kelvin with no negative numbers. 1 degree Celsius is equivalent to 1 degree Kelvin. Absolute zero is where the kinetic energy of atoms is zero, well, theoretically. It's easy to switch between Celsius and Kelvin. Just subtract 273.15 from Kelvin to get Celsius, or add 273.15 to Celsius to get Kelvin. For example, 20 degrees Celsius is 293.15 Kelvin. And make sure you don't say degrees Kelvin. It doesn't actually use degrees, it's just Kelvin. When particles of a gas are heated, the particles will speed up. This means that the kinetic energy of the particles has increased, and therefore the temperature of the gas has increased. But the reality is that not every particle is moving at the same speed. We'll start by viewing a scale that measures the relative number of particles at different speeds. Particles are always moving unless they're at absolute zero. These few particles with a slower speed have less kinetic energy, and these particles with faster speeds have higher kinetic energy. But we can't easily take a snapshot of just one or a few particles. When we measure the temperature, we're looking at the average kinetic energy of many particles. This bell curve may represent a fairly warm temperature, and this curve a relatively lower temperature. There are lots of particles that have the same kinetic energy at both of these temperatures, but again, temperature is the average kinetic energy of particles. If the temperature drops to absolute zero, the kinetic energy of the particles comes to a halt. This is where the Kelvin scale starts, which means that there are no negative numbers in Kelvin. It begins at zero, making it better than Celsius, but there's another reason that Kelvin is better than Celsius. It's better mathematically. If the temperature rises from 10 to 20 degrees Celsius, it appears to have doubled. But if you convert those numbers to Kelvin by adding 273, you'll see that the numbers haven't doubled at all. Kelvin is accurate when it comes to proportions, so use Kelvin in all of your chemistry calculations.